I'm Bruce Weil, the Chief Engineer for CAPI, and we're going to make an announcement. We are making an announcement today of the CAPI SNAP framework. Greg mentioned it in the opening slides of this section. SNAP stands for the Storage, Network, and Analytics Programming Framework. The concept was initiated at OpenPOWER Summit 6 months ago. So we've gone from a concept 6 months ago to a demo today and product release at the end of the year. And I brought a prop because there's really two stories here. JT remembers this prop. The story one is about CAPI SNAP. The story two is about how we formed a collaboration across 7 different companies and created an enablement tool, this CAPI SNAP, as a team under OpenPOWER Foundation. So when we were at OpenPOWER Summit in San Jose, a couple of us had some ideas. We sat down. Is Rob here? Rob Taylor sat at the table with us. We got JT's name on here. Nalitech was at the table, Xilinx was at the table, etc. So we started drawing these pictures on that notebook, and it very quickly became a document. And we said, hang on, we have to make sure we have the right governance over this because it's multiple companies all participating. And you see the names of the companies that end up working on it across the bottom here. We decided on basically day one that this wasn't going to be an IBM-owned thing. This was going to be an OpenPOWER-owned thing and was going to run under the OpenPOWER Accelerator work group as a subgroup under there. And that's where it remains today. We report results every 2 weeks into that work group, and all of our documentation goes under OpenPOWER. And a big...
There's a guy up there watching.
I'm hitting him with a laser. One of the reasons, one of the driving forces is that we are making everything about this framework open. We're going to put the open source out on GitHub at the end of the year. We are using GitHub, a private version of the GitHub now. We will turn that into the open version at the end of the year. Right from day one, 2 significant directives. This is now on CAPI SNAP. Number 1, we have to make it easy for programmers to start to use acceleration. Program ISVs, developers. We do that through a simple API and making it much easier to create acceleration IP. That's what this framework is about. And then, of course, the second part is that we're going to make this an open source. So what does this framework look like? We have an application running on a Power server over here. That's your application with its virtual address space. And in yellow, we have a CAPI library, framework library. And here's the simple API. He's coming back up, isn't he?
That's paid ad placement.
That's connected to a CAPI-enabled card with a framework on it and the personalized action code. And I'm going to flip back and forth here. This is a network card, but we can also do this on a storage flash card. So you can have storage, Ethernet, anything hanging off of this network card. You can put your data out here on the flash card. Both these cards will be enabled as we move forward. All of this framework will move forward to Power 9 and CAPI 2, and it will move even further on with OpenCAPI. The framework will be supported all the way through. So the key is this API and the simplicity of it. Fundamentally, a programmer calls a function, and that function has a source. Where do I get my data from? It has an action. What do I want to do to that data? And it has a destination. Where am I going to put the data after the action has been performed on it? So maybe your data is out on a storage area network here, and you want to do a search on it. So you pull the data in here, you do the search right here, and you send your hits and put them into your virtual address space. That's a basic use case for it, a search, and that is fundamentally one of the demos that we showed today. Well, why is that cool? It's cool in two different ways. Number one, you're putting the action closer to the data. That's important because you have a lot more bandwidth here. On some of the cards, you can get multiple 100 gig Ethernet connectors here versus the 8 or 16 gig PCI connector here. So now we're kind of blowing traditional computer design out of the water where you're making an unbalanced system. So if you have more data bandwidth here because you can do work here, you need less data bandwidth here. So you're moving your compute closer to the data in this case, and you're computing faster because it's on an accelerator. So you've got two different benefits that come out of that use case. Same kind of card, maybe you have Ethernet packets coming in. And you can do all kinds of work on that Ethernet packet. Maybe you're doing security, maybe you're doing some kind of checking on that. And a second demo that we will show today has Ethernet packets that we run statistics on here and put those statistics down into the virtual address space. So two different examples we'll show today, and either of those cards will have it. So the API is simple, source, action, destination, and then we get into the action code. Well, rather than doing this in RTL and VHDL or Verilog, we have enabled programming languages like C and the Go language to write this action code. So this is what it looked like for an API before CAPI Snap. You had to interact with an install library code and the operating system and set up and create your AF, make a connection to your AFU. Then you had to go over and open the AFU and start your process and then stop it. All kinds of low-level work, all in order to call a function on the accelerator. This is computer engineering work. But if you want to enable programmers, you've got to make a leap to this source, action, and destination. So that yellow library on the previous card here, this framework library, takes care of all these low-level details so that the application just needs to say, hey, here's my source address. It could be out in the Ethernet address. It could be a storage area network. It could be main memory. It could be something else on the card. Here's my action. You can have multiple actions on the card. Maybe you have a search and a merge function for databases or an intersection function out there. You can have multiple actions on the card, so you're telling it which action you want to perform. And finally, you have the destination. This is where I put the data when I'm done. And it could go right back to the same area as the source. It could be any one of multiple destinations. So that's the API. That's simple with a function call. For the accelerator code, the other side of the equation, making this easy, this is what it looks like in our workbooks as we talk about, this happens to be a case where we're doing a bunch of different commands to fetch data, to pull data out of the system memory and get it over to the device. This is, again, written for computer engineers, not programmers. Programmer wants to write code. So here's our search code. Couple lines, we're looking for an image. This is, basic C++ here. And the framework itself manages moving all the data and getting it over into the action for you. So now, as an application developer, all you have to do is think about your action, your sort, your merge, your statistics. So those are the levers that we put into this CAPI Snap in order to make it easy for programmers, developers, and ISVs. Finish up with some key dates and actions. November and December, we have a limited number of early users. We've got a couple signed up. If you are interested in, or if you're an ISV and you're interested in partnering and trying out the CAPI Snap framework early, send an email to capi@us.ibm.com. We will get you the forms and ask you the questions needed, and you have potential to be an early partner. Otherwise, in January, the entire framework will be released with example code, so you can pick that up and take it and work with it, modify it, use it however you like. So that's CAPI Snap. We have 2 demos tonight. Tomorrow at Randy's session, we have a programmer version of this where we'll go a bit deeper into what these interfaces look like. And then later in the morning at the Accelerator 2 session, we'll have a little bit more about what's built into those yellow boxes out on the FPGA and how things are working under the covers. So 3 more opportunities to learn more about CAPI Snap, 2 sessions, as well as the demos this evening. So I encourage you to stop by the booths if you're interested and learn about it. Thank you very much.